Hello everyone, this is Muhammad Javed, lecturer mathematics, International Maritime College. Today we are going to learn about Cramer's rule. Cramer rules help us in solving some system of simultaneous linear equations. So this is a system of simultaneous linear equation. It has two variables. It has two variables, x and y, in both the equations. And then if there are two equations, variables, then there will be two equations. So this is first equation, this is second equation. First variable is placed in the first term, second variable is placed in the second terms. Then there is symbol of equality for both equations, and these are constant after the equation. So this whole side, the left side, contains those terms which involves variables, means x and y. If we have three variables, then it will become x, y, z equal some constant, and then there will be 1, 2 and 3 equations. Anyways, if there are 4 variables, then there will be 4 equations. Let's okay, what's the procedure? So let's go for the procedure. First of all, it is split into or put into matrices format. I'm going to clear my screen to explain it in a better way. Okay. So first of all, we put the system of these equations into matrices, two matrices, one on the left, other on the right. Okay, and actually the left matrix can be split into two matrices. One is this matrix, another is variable matrix, and the right side is the same. So if you see, a1 is a number before x, so it will be written here. a2 is the number before x, we call it coefficient, so it will be written before here in the first order. The same way b's, so b's will be written here. So if we multiply these two matrices, again we get this matrix, and when you are writing this into matrix system, so there will be only one equation instead of two. Okay, let's move for the next. And the first matrix, which we call the matrix of coefficients, we call it A. Okay, so in this A matrix, when we replace this column by this column or this column, then its new name becomes A1. Okay. And when we change this column of B1 with the same constants, then we name it A2. Look, in A1 the B1 B2 remain same, and the A2 the A1 A2 remain same. A1 mean that replace that column matrix into first column, and A2 mean that constant matrix we put into second column. Okay. Now Cramer says that A1 determinant divided by A determinant is the answer for x, and they are determinant notations. just we replace the bracket by bars. How to solve them? Actually, we multiply these two, then minus these two, multiply these two minus these two, and divide. After division, that will be our answer. So see, if we divide the same here. So now I'm explaining with some animations. K1 and B1 are these two, and K2 and B1 are these two. Similarly, for the lower matrix or the bottom matrix, so A1 into B1 minus A2 into, and the same methodology is applied to the next determinant for Y. Okay, there is an example regarding electrical engineers, which is dealing with the currents in a circuit. We have two equations, I1, I2, and so the engineer has modeled these two equations, and we are going to solve I1 and I2 using Cramer rule. So if we look at the left side, so this is 1 because here it is 1. Now the next is 2, again it is 1, so with a distance we write 1, 3, and then plus 3. This is a matrix, okay? And the the variable are I1 and I2, so here we write I1 and here we write I2 equals that 3 and 7. So this is a matrix A. For the others, we don't need to give them name. If we give them name, no problem, but it will make the writing process longer. This is A now, so it has two variables I1, I2, so we need two more matrices for which we will take determinant later. So let's do determinant for this one first, A. So 1 multiply 3, so this is 1 multiply 3, then minus, this is minus, this minus is, you can say, the part of fixed part of this process, and then 1 and 2 is this, so of course it comes 1. Now another matrix, so A1, so if you see, the first column is actually this constant matrix, and the second column is the actual column of the A. Now we solve it, so 3 into 3 and 1 into 7, this is 3 into 3 and 1 into 7, and I told you minus is the part of this definition. Now A2, so this time 1 and 7 is placed in second column, and if you see, so 1 and 2 is the actual column. Now let's solve it. So 1 7 minus 3 and 2 equals 1. Now according to definition, A1 determinant by A, so A1 determinant value is 2 and A determinant value is 1. So the current is generally measured in amperes, I think. So here it is not mentioned about the unit, but if you want to write, you can. Okay, I2 is A2 by 8 and 1 by 1. This is also, I think, in ampere, but it's not given, so if you don't write, no problem. Now it was easier for 2 by 2 matrices, but what about 3 by 3 matrices, 4 by 4 matrices, 5 by 4, and even more bigger? So this will be the first step for all bigger matrices in size. So I take three simultaneous equations: variable x, variable y, variable z, and there are three, so 1, 2, 3 equations are there. Now first of all, matrix form. Okay, so matrix form is almost it. All the numbers written in front of x, in front of y, and in front of z, they are written at distance, but take care, the x numbers are here, the y numbers are in this column, and the z numbers are in this column. And this is the matrix we will start with, and this is A. Now first of all, let's do its determinant, then we will go to A1, A2, A3. Here will be 3 more matrices because we have 3 variables. So okay, they are going first. I think I have followed book here, so let's complete first the matrices. That I will explain in examples. So this is basic definition. So on the basis of A, how matrix A1, A2, A3 are achieved. So the same concept, see, this is A1. So in A1, this constant column matrix is placed in 1 here. Okay, this is A2. So A2 means that it will be placed on column 2, and A3 means it will be placed in column 3. And notice that all other things are same. This was for x, so x written. This is for z, so z written. And A2 is changed, A3 is changed. Here A3 change, here column 3 change, here column 2 change, and here column 1 change according to given matrix. The further definition is similar. A1 determinant by A determinant, and I will explain this determinant. This determinant is little tricky and needs more information and skills. So y, then z, so 3 determinant. If there is another variable, so it will be A4 by A determinant, and so on. Let's do an example. I'm taking this example from your book, again electrical engineering, regarding circuit voltages. This time voltages, not currents. So we got 3 equations. First of all, matrix form. After matrix form, A is important, and now here I will tell you how to find determinant. So determinant, you know this, I am writing the same matrix A. If you notice this, I am writing the A contents, this completely A contents, and this part, the red letters, are actually the first and second column repeated again. Look, first and second column repeated. So write A determinant or A numbers, and then first 2 columns. All the time first 2 columns in 3 by 3. make clean my screen. Okay, so red letters mean they been repeated. Now what we do, we multiply this with this, and similarly 2 and 2 minus 2 and 2 and 1 2 2. Okay, then we will do multiplication for these 2 3, then for these 3, and then for these 3. So this way there will be, this is for first diagonal multiplication, then we write plus second diagonal matrix, second diagonal multiplication, which is this, then plus third diagonal multiplication, and then we put a bracket and we write minus, and now we start from other side. So for these 3 we write them, or we multiply them, then plus. For these 3 we multiply all of them and plus. Now for this diagonal, which is this one, and this will give us answer. The traditional technique of this is a bit longer and takes more time to cover it. I have seen this technique somewhere on YouTube. Now I am sorry to recall that channel, but thanks to that channel that I got this simple technique, and no more you need to go for longer calculation. So this is final answer. If you see, so there are, look, the first 3, second 3, then bracket, minus, plus, and plus. Final answer is coming this. If I clean my screen, you will see my net slide operations. Okay, so look, these 3, then these 3, then these 3, we put bracket, write minus, again square bracket, 3 3, and so on. So this is our A1, where we placed first column with the constant column on the right side of the equations. Now again note, this is the matrix, actual matrix, and they are the repeated first 2 columns. This is actual, and they are the repeated. So the same way, we start from this diagonal. When we multiply them, it will come this, then plus. We come to next diagonal, these 3, the third diagonal, put bracket, write minus, and now for this we are starting from the other diagonal, other end, then this, and the final answer is minus 39. Now in A2, so in A2 we replaced column A with that constant matrix here. We replaced this column with the constant column of constants on the right system, on the right side of the system. So we write A2 first as it is, and then we repeated the first 2 column here. Then we go for diagonal multiplications. So first diagonal, second diagonal, third diagonal, then from the other end, first diagonal, second diagonal, third diagonal, there should be minus between them in the both square bracket. Answer is coming 13. A3 is also not so much different. A3, this is the column of constant given on the right side of the system. We replaced it here. Multiply this diagonal, then from the other end these diagonals, and answer will be minus 13. Okay, I am writing for myself this thing we calculated in the previous slides. Okay, so this we did earlier, all of 3, and A3 we did here. So if you write for yourself here, A3 equals minus 30. Now x1, this is x, actually they are voltages, but I'm used to write xy, so you will find me always writing instead of the actual variable I generally write xyz, but no problem, it is understood that we are doing this for voltages. And this is V3 x, so A1, A2, A3 determinant, and I think here is a little problem. 13 divided by minus 13 is coming minus 1, so this is minus 1. Okay, now in voltages, I don't know minus 1 play any role or not. I am not good at electricity and physics, but anyways the solution is coming minus 1. Now I'm not clear, is there the concept of minus 1 voltage or not, but I don't think there is concept of minus 1 voltage, but it can be because not my field. Let's go to another. Okay, now this is a exercise, so I think here we got no problem. In question 2, when you will do practice, look, 3 variable I1, I2, I3, and the second is also fun, but the third you see here supposed to be I3 as well, because I1 is given, I2 is given, where is I? So you just write with it plus 0 I3 equals 9, right? So then you solve it. When you come to this is fine, but in the second one there is little trick. They have changed the order, so order is very important in matrices. So minus 1.5x and plus y equals minus 5. So you should write like this. Since this is customary that mathematician write the positive term first, so y is positive, so they write y first. But when you are doing this in this matrices order is important. X and Y must be written in proper order. Or look at the situation of the question, which variable is coming first. Well, now if we discuss this one, because you will solve it, what is problem here? So I think if you look at carefully, in all this Cramer's rule, all those terms which is got variable will be written on the left. So left, so we should write 3f plus 5g equals this minus 16.1 will go to the other side, and this will be (16.1), and the same is here. 2f minus g equals, and second side it would be 3. So well guys, I hope you will enjoy it more than the online session where we always see problem with internet, with sounds, blah blah blah. So if you have any problem, come online and ask me, or WhatsApp me, or use your email, call me, whatever you can do. Okay, thank you, see you.